Hello, my name is Simon Timperley from the International Food Safety and Quality Network. Welcome to edition 98 of the Food Safety Fridays webinar program. Today we are going to be talking about environmental monitoring programs with Kantha Chennai from AIB International. But first, a few things to talk about. The sidebar, if you've not joined us before, is where you can see the comment stream, where you can say hello to each other, tell us where you're from, ask your questions. At the end of the webinar, we'll be having around a 30-40 minute PowerPoint presentation, and then we'll have Q&A. So you'll have your opportunity to type in your questions, and we'll get to them later. I need to say that the Food Safety Fridays webinars are sponsored. The program is sponsored by some kind organizations, and they are AIB International, DNV GL Business Assurance, Trace Analytics, Metal of Toledo, and Safe Food 360. They help to support this program and bring free education regularly, and you get a free certificate of attendance at the end of today as well. Okay, right. At this point, I'd like to introduce you to Kantha. How are you doing, Kantha?
I am pretty good, Simon. Good morning.
It's good to have you back again. Very important and interesting topic we're looking forward to today. Can you tell the audience where you're calling in from, Kantha?
Okay, good morning, everyone. This is Kantha Chennai. I'm calling from Manhattan, Kansas. So we are in the central time zone in the US.
So it's 9 a.m. for you at the moment?
Yes, sir.
It's 3 p.m. for me, and well, we've got people from all over the world, so all time zones, but everybody's welcome. If you want to get your slides up, Kantha, I'll tell the audience about next week. Ladies and gents, in the sidebar, you will see a picture of David Rosenblatt. And next week, we're going to be talking about effective food safety training in the digital age. We aren't robots yet. David's a very engaging speaker, and I'm sure you'll get a lot out of that. Please do click on the register now. It'll open a new window and you can sign up here and now, or just respond to one of the emails we'll send over the coming week. Right, I'll be back for the Q&A later, but for now, I'll hand you over to Kantha. Okay.
Hey, thank you, Simon. Good morning, everyone. Welcome to How to Set Up a Sampling Zone for an Environmental Monitoring Program, educational webinar designed to enhance food professionals' knowledge on implementing an effective hygiene zoning and an environmental monitoring program. My name is Kantha Chennai. I'm the Director of Microbiology at AIB International. Before I get started, let me go over a little bit of housekeeping. The duration of this webinar is about 60 minutes with 45 to 50 minutes talk and 10 to 15 minutes for Q&A session. Please hold your questions until the end of the webinar. Meantime, questions can be entered via the Q&A widget on the right-hand side of your screen. The questions will be answered sequentially. If there are any unanswered questions within the allotted time, then it will be answered later individually. Following is today's agenda. First, I would like to talk about the importance of food safety. What is a hygienic zoning? Why do we need hygienic zoning? Objectives of hygienic zoning, application of hygienic zoning. So this is where I will spend majority of my time talking about the importance of conducting environmental risk assessment before we go for a hygienic design. And I'll talk about the importance of hygienic zoning for an effective environmental monitoring program, summary, and we will finish off with the Q&A session. Achieving food safety is the topmost priority for any food manufacturer. Maintaining hygiene condition in the food processing environment is critical to maintain the quality and microbiological safety of the finished product. Microorganisms are generally introduced into the food processing environment through a wide range of, number one, raw ingredients, pest, air, equipment, water, and through employees. In most cases, raw ingredients Improper hygiene zoning and traffic pattern are the main sources of cross-contamination. According to ICMSF, that is International Commission on Microbiological Specifications for Food, good hygiene practice is very critical for food safety. Cross-contamination and food safety. Every year, foodborne illness outbreaks affect millions and kills thousands in the United States and other parts of the world. Additionally, tainted food has cost the food industry billions of dollars in recalls, lost sales, and other legal expenses. The past data clearly show that cross-contamination is the main causes and sources of foodborne illness outbreaks. Every week, one can see hundreds of recalls due to contamination of finished product with pathogenic bacteria. Please note that all these losses are 100% preventable if we have an effective hygiene zoning and effective monitoring program. Even though the facility has a validated kill step, the post-lethality recontamination remains a serious concern and challenge. At the end of the day, it's the responsibility of the food manufacturer to make sure that finished product is safe. Hence, it is critical to implement proper hygienic zoning and an effective environmental monitoring program in a food establishment to prevent cross-contamination, assuring the safety of the finished product. Why do we need hygienic zoning? The most important obvious reason is to differentiate areas within a facility to minimize product cross-contamination. Although a good hygiene zoning can prevent or control cross-contamination of product from number one, biological agents that includes microorganisms and pests, number two, chemicals which includes allergens, and number three, physical agents. In this presentation, more emphasis is given to control of microorganisms and building an effective environmental monitoring program based on hygiene zoning principles. We need hygiene zoning to comply local regulatory requirement. Sometimes the local state or agencies will have certain standards to be met. So in that case, we need to maintain the hygienic zoning to comply local regulatory requirement. Also, we need hygienic zoning to optimize the time and resources for cleaning and sanitation procedures. This is very important. The reason is very simple. If we don't do a good job of classifying or demarking hygiene zones in a facility, then we end up spending too much of time and resources in fixing cleaning and sanitation procedures in a wide area which may not be necessary. Excuse me. Worldwide, several organizations, example, NSF, European Hygiene Design Group, 3S Sanitary Standards, etc., have developed various hygiene designs, standards, and procedures. However, when it comes to assuring finished product food safety and its relation to hygiene zoning, all are in general agreement. One of the biggest advantages of a proper hygienic zoning is that the process is controlled on the spot by the employee and not by a remote microbiology lab or an outside inspector, food inspector. How to achieve food safety? There is no hidden secret or formula to achieve food safety. One needs to implement an effective good hygiene zoning, GMPs, HACCP, validated preventive controls, an effective cleaning and sanitation procedures, and an effective environmental monitoring program as a verification activity to make sure that everything is working as per the predetermined standards and specifications, and then it makes food safe, right? So please note that despite of implementing all the necessary components of food safety plan, if we do not have a good hygienic zoning, then the food safety plan fails without a doubt. As someone rightly said, food safety and environmental hygiene is inseparable. Hence, it is rightly called as one of the foundational pillars of food safety program. So let's understand what is a hygienic zone in a food establishment. Hygienic zones are designated area in a food establishment that classifies the individual production areas by their environmental hygiene risk and demands specific function and hygiene standards. Okay. So please note that it is not just demarking the facility with the different colors. It's more about adhering to specific function and hygiene standards. In simple, a designated area with specific function and hygiene standard to prevent physical, chemical, and biological cross-contamination of the environment, equipment, raw materials, employees, process, and finished product. Objectives of hygienic zoning. There are two main objectives related to hygienic zoning. Number one is to identify and separate high and low risk areas based on the microbial risk assessment within a plant environment. Number two is to protect cross-contamination of product and process with an ultimate goal of preventing adulterated food products from entering commerce. Please note that the level of hygiene condition should be proportional to the environmental risk to the product or process. Okay. The ultimate goal is to establish hygiene environmental conditions necessary to manufacture safe food product as per the regulatory and consumer requirement. Hygienic zoning, assessment and considerations. So before earmarking areas within the food establishment, it is important to conduct environmental risk assessment or microbial risk assessment. One can also use HACCP principle to identify vulnerable zones within an establishment. The first task is to bring together individuals familiar with the operations to form an environmental risk assessment team. This team may include the plant quality manager, the plant or corporate microbiologist, line supervisors or operators, sanitation supervisors, workers, plant engineer, and people from product development because they know the sensitivity of the product. So once the team is formed, the next step is to conduct a systematic study of the building and equipment design, raw ingredients, employee and equipment traffic pattern, operations that generates potential vectors or agents such as dust, air, water, etc., and the condition of storage, packing, and distribution. So you need to assess all these factors for product adulteration, potential product adulteration chances. And do not forget to consider maintenance and equipment storage areas too. Particularly, give more emphasis to crossover areas. This is very important. So there are chances like which is inevitable to have crossover areas, but for those areas, give more emphasis. Review the correct cleaning and sanitation procedures specific to the zoning areas. Also, it is important to check the history of the facility. Example, areas prone to dust, water vapors, leakages, mold buildup, bird nest buildup, other pest activities, traffic, etc. Once the zones are identified, it is important to distinguish zones using color-coded markings or physical barriers at transitions and entry-exit points. At the end of the day, it aims to identify the sensitive areas which might contribute to a hazard. Here, the ultimate objective is to identify the process flow where potential problems are foreseen and forestalled. Okay. Applying Hygienic zoning in a food plant. Once the environmental risk assessment is completed, then it is very critical to demark what constitutes the primary pathogen control area or PPCA. This is very critical. Prepare a new facility map with a designated hygiene zone such as basic GMP areas, transition areas, non-processing areas, etc., with corresponding hygiene and traffic rules. The hygiene zoning map can be developed using an Excel or AutoCAD or hand-drawn. Once the hygiene zoning map is created, it should be communicated to all the employees, including office staff. Also, it is important to train all the staff on which specific procedures apply to their job function and understand its importance. This is very important. Okay, so the training is very, very important to achieve food safety. Additionally, it is important to restrict the outside visitors. So all the visitors, contractors, and service providers, such as pest management personnel, should be informed of the zoning plan prior to entry. This is important. Let's understand the actual meaning of different hygiene zoning. As mentioned earlier, worldwide, several organizations have developed various hygiene designs, standards, and procedures for meat processing, beverage, dairy, bakery, etc. However, due to time limitations, I will talk about the general principles behind segregating zones based on the level of risk and function. In general, a facility is classified into four hygiene zones. They are non-manufacturing zones or zone 4, transition areas or zone 3, basic GMP areas or zone 2, primary pathogen control areas or zone 1. Non-manufacturing areas are areas remote from the product processing areas. It includes offices or business areas with zero production activities. Transition areas, as the name suggests, it is an area between high versus low risk areas. These areas could be zone 3 based on the nature of the product. These are areas where raw ingredients and products within a package exposed to environment for a very short interval of time. Basic GMP areas. These could be either zone 2 or zone 3 areas where the product is exposed to environment for a short period depending on the nature of the operations and demands highest level of GMP, SOP, cleaning and sanitation procedures. PPCA or primary pathogen control areas are those areas in a facility where products are exposed to an environment after cleaning or a kill step. This demands highest level of sanitation and hygiene standards. In general, no water is allowed in these areas because water is very important factor that can trigger microbial multiplication. Please note that PPCA or primary pathogen control areas is easy to define, but other hygiene zones are defined conceptually. This is very important, not by a rigid physical description always. It depends on the risk assessment. So it is important to understand the concept of hygienic zoning. This slide shows a typical example of hygienic zones on a facility map. Typically, a zoning map indicates different hygiene zones such as zones 1 to 4 or high to low risk areas, major entry-exit points, transition areas, employee traffic, equipment traffic, waste collection and movement of products. This includes both raw and finished products. In general, a complete zoning plan consists of zoning maps, number one, number two, standard procedures and hygiene practices specific to each zone, number three, virtual demarcation or physical barriers. Number 4, monitoring procedures. Number 5, verification and documentation. Hygienic zoning guidelines. It is vital to follow the rules or procedures related to specific zones for food safety. One needs to make sure that all manufacturing activities must take place in the appropriate areas or zones, example, zone 1 or 2 or 3 or 4. Wherever possible, highly sensitive areas should be separated by a physical barrier to avoid cross-contamination. I strongly recommend this. For example, in infant formula manufacturing plant, it would be appropriate to segregate the PPCA area using a physical wall instead of color-coded markings. Also, it is vital to have dedicated staff in each zone to achieve highest food safety throughout the process. Determine each zone's specific cleaning and monitoring requirements and implement monitoring and verification activities to assess the effectiveness of hygiene zoning. Please note that it is not always necessary to have exactly 4 or 3 hygiene zones in a facility. Some plants, depending on the nature of the product, has a plan, and risk analysis may require 2 or 3 or 4 zones. So it all depends on your environmental risk assessment. One of the most frequently asked question is, how far is zone 3 from food contact surfaces or zone 1? And is there any footage to be considered? So this is the most commonly asked question. My answer is no. To my best, there is no rule to determine zone 3 based on the distance unless you have specific instructions or guidelines from your management or from authoritative agencies. In fact, some plants use the term critical for zone 1, high risk for zone 2 or 3, and medium or low risk areas for zone 4. Again, this should be okay as long as they continuously monitor and verify the hygiene condition of the facility and implement appropriate corrective actions assuring the safety of the finished product. Classifying a facility into 4 zones based on the sanitary zoning concept is commonly accepted industry standard. Importance of traffic pattern for food safety. Here I would like to use a famous quote from Benjamin Franklin, a place for everything and everything in its place. The short meaning is things should be kept in order in their correct positions. Generally, traffic patterns of raw materials, employee, equipment, packaging materials, waste, drains, etc. in a food establishments are often implemented out of convenience rather than with food safety concept in mind. This is not correct. Always design the traffic pattern based on the risk analysis. The first step is to identify routes and potential associated risks. Sometimes it is inevitable to have crossover. In such cases, an effective control must be implemented. Example, hand washing station, boot washing station, barriers, etc. Importance of a product flow. Establishing a correct traffic pattern is critical for food safety. A fault in product flow design can create a detrimental effect on your food safety program. The pictures in this slide are self-explanatory. Always come up with the best possible product flow design for a successful food safety program. Please note that designing a product flow that is linear so that product moves flawlessly downstream without interruption is key to success. Excuse me. Hygienic zoning and food safety. The success of any hygienic zoning or design depends on various factors such as GMPs, cleaning and sanitation procedures, pest control program, validation of preventive controls such as kill step, SOPs, and good hygiene post-process handling practices. Please remember that apart from designing an effective hygiene zoning, it is important to make sure that all other supporting elements or components of a food safety program are working fine as per the standard. Otherwise, hygienic zoning and overall food safety program fails. It is very important to understand the purpose or objectives behind implementing hygienic zoning in a food establishment. Requirements for common GMP zones. In addition to hygiene design, specific function and traffic pattern, effective implementation of GMPs and SOPs are essential to assure consistent quality and safety. Hence, it is the responsibility of the concerned team or management to continuously train and monitor the effective implementation of hand washing procedures, boot sanitation procedures, safety gadgets, jewelry policy, eating policy, sick employee policy to achieve food safety. Requirements for high sensitive zones, for example, infant formula manufacturing facilities. This is the area where highest level of hygiene is required. A processing room in high sensitive zones must be completely contained. This is very important because even a short exposure of product to the environment can result in a severe food safety hazard considering the sensitivity of the final consumer, that is infants. As mentioned earlier, one needs to conduct a comprehensive environmental risk assessment before designing a hygiene zones and SOPs. SOPs such as locked doors with restricted access, air balancing, filtered air, hygiene transfer, and entrance, etc., must be strictly implemented in high sensitive zone areas. Now I will talk about the importance of hygienic zoning for an effective environmental monitoring program. Utilization of hygienic zoning concept to build an effective environmental monitoring program. To identify environmental swab sampling points, the best practice is to use the hygiene zoning concept. As described earlier, using sanitary zoning concept, divide the facility operations into 4 zones such as zone 1, 2, 3, and 4 based on vulnerability of ready-to-eat food that is exposed to the environmental conditions. For any RTE manufacturing facility or ready-to-eat manufacturing facility, it is very critical to define what constitutes highest risk area, that is zone 1, to lowest risk areas, that is zone 4, for product contamination. Please note that a proper hygiene zoning is the foundation for an effective environmental monitoring program. If the hygienic zoning is not proper or incorrect, then EMP fails and can lead to cross-contamination of the finished product. Let's understand what does FDA FSMA say. So this is applicable to all the FDA registered food manufacturing, RTE food manufacturing facilities in the US and those foreign facilities who export RTE foods to America. FDA's Food Safety Modernization Act, signed into law in 2011, shifted the main focus from addressing food safety failures to preventing it. That means FDA is more focused on preventing cross-contamination and product adulteration at the plant level than addressing food safety failures later. According to the FSMA, Food Safety Moderation Act, one must conduct environmental monitoring and product testing if a ready-to-eat product is exposed to the environment before it is packaged, and the packaged food does not receive a treatment that would significantly minimize an environmental pathogen. So the statement is very, very clear. If the answer is yes, then EMP is must. Also, please note that whenever the FDA declares that the food is adulterated upon inspection under the section 402A4, it is actually an environmental contamination charge. Okay, as you all know, section 402A4 deals with food products found to be prepared, packed, or held under unsanitary conditions which cause them to be adulterated. In my opinion, EMP is must do for most RTE foods. According to FDA, environmental monitoring program and product testing are verification activities. Please note this. So FDA considered environmental monitoring program, including product testing, as verification activity to make sure that all the other components of GMP's SOP kill steps are working fine as per the specification. I hope this is clear to everyone. So this is not a validation activity. This is a verification activity. There is a misconception about the actual role played by the environmental monitoring program. Some thinks that EMP's actual role is to validate the cleaning and sanitizing methods. No, this is not correct. EMP is more focused on validating cleaning and sanitizing frequencies and all the programs of good manufacturing practices. I'm going to repeat this again. EMP, that is Environmental Monitoring Program, is more focused on validating cleaning and sanitizing frequencies and all the programs of the good manufacturing practices. That means it will provide important information about whether your GMPs, including cleaning and sanitizing practices in hygiene zones, are good enough to keep the pathogenic bacteria under control. And also, please note that having an EMP does not make food safe. Okay, because EMP provides very good information on harborage sites in a facility based on which you need to take corrective actions, and then it's gonna make food safe. Okay, I hope this is clear to everyone. Okay, I think it's time for polling question 1.
Yeah.
Simon, you want to take over?
Mm-hmm.
Okay.
Yeah, Kantha. Yeah, question to see if you're paying attention and to see what you know. Why is it recommended to test zone 1 for indicator microorganisms? Why not for pathogens? So, do you want to type in the sidebar and have a see what you say? So why is it recommended to test zone 1 for indicator microorganisms? Why not for pathogens? Anybody? Might take a few seconds. Anybody? Here we go. Kerry Bowman, you will be shut down if you test positive for pathogens. Indicators are the gateway. You want to establish the potential for an issue. Pathogens are long and difficult to test. Zone 1 is normally kept sanitary. To stop pathogens before they reach product, pathogen takes longer and also more sparse, harder to find. Sanitation level pathogen is hit or miss. Indicator organisms give a better understanding of total risk. It will be already too late. Hey, you're laughing, Cantha.
No. Good inputs,
Okay, what do you think of that? What are we hitting the mark or?
Okay, great feedback, guys. Although there is no hard and fast rule to test zone 1 for pathogen or indicator microorganisms, but it is highly recommended not to swab for pathogens in zone 1 environment, as this is not an effective way to capture the contamination. Okay, so and also if zone 1 tests positive, then it is most likely initiate a recall situation. So using indicator organisms, one can build an effective EMP program and still make the finished product safe. So we can use indicator organisms which are present in high number, easy to enumerate, and less expensive. And also, like most importantly, zone 1 is not an effective way to capture product contamination. So that's the main reason. Okay. So this is the answer, which I already explained. So zone 1 is the most sensitive to contamination, and it includes all direct food contact surfaces in the plant. Okay. So some of the examples includes blenders, conveyors, utensils, work tables, etc. It is recommended not to swab for pathogens in zone 1. As I mentioned earlier, this is not an effective way to capture product contamination. And one can use indicator microorganisms in zone 1 areas. However, in rare cases such as continuous positive zone 2 for pathogen or positive finished product or a recall situation, then zone 1 should be included for testing pathogens. Otherwise, I do not recommend testing zone 1 for pathogens. I hope this is clear to everyone. So how many environmental swabs one need to collect from zone 1? So this is again important because zone 1 is the product contact surface. People always think that we need to collect more samples from zone 1 areas. So the total percentage of testing from zone 1 is normally between 10 to 20%. That is, if you are planning to collect 100 environmental swabs, then dedicate 10 to 20% of for zone 1 areas. Otherwise, you are wasting your resources. So more samples need to be collected from zone 2 and 3 areas. We'll talk about those things in detail in the next slides. Okay, it's time for polling question 2. Simon?
Yeah. Okay, you can see the question there on the slide. What is the percentage of swabs that we need to collect from zone 2 areas? Just type in the sidebar again. What is the percentage of swabs that we need to collect from zone 2 areas? Frank, 10 to 20. He's first off the mark. 30% Tamai, 40 to 60 Amit, 30 to 40 Irene, 10 to 20, 30 to 40. I'd say the average is around 40.
Wow, that's good. Yeah, I think they're all in agreement with my answer. So about 40 to 50% of total swabs are taken from zone 2 areas because this is the area in which environmental contamination is most likely to affect the safety of the finished products. You guys are correct, like nearly 40 to 50% of the total environmental samples should be collected from zone 2 areas. So zone 2, these are non-food contact areas in the plant that are very closely adjacent to food contact surfaces or products. Some of the examples includes equipment frame, maintenance tools, drip shields, chain guard housings, etc. In general, this is the area where environmental contamination is most likely to affect the safety of the product. So the focal point of zone 2 testing will be to validate the equipment sanitary design. Please note this point. So the main purpose of collecting samples in zone 2 is to validate the equipment sanitary design. It is recommended to test zone 2 areas for indicator as well as pathogens. So you can test both indicator as well as pathogens in zone 2 areas. Again, one can designate the zone 2 based on the sensitivity of the product and conditions. In some cases, if the roof is very close to the product contact surfaces or product, then roof will be considered as zone 1 instead of zone 2 or zone 3. Okay. So in some cases, as I said, you need to understand the complex concept of hygienic zoning, and then you have to implement and you have to designate the zones based on the nature of the sensitivity of the product. As I said earlier, if the roof is very close to the product, usually roof, walls, drains, floors are considered zone 3, but in some cases, if the roof is very close to the product contact surfaces or product, then roof will be considered as zone 2 instead of zone 3. Okay. Similarly, if the drip shield is very close to the product contact surface or products, then it can be included in zone 1. What I'm trying to say here is, based on the microbial risk assessment and nature of the product, one can modify or alter the hygiene or environmental swab zones with an ultimate purpose of achieving food safety. So the total percentage of environmental swab testing from zone 2 is normally like 40 to 50%. That is, highest number of samples are taken from zone 2 areas. Please note this. This is very important. I think it's time for another polling question, Simon.
Yeah. What is the indicator bacteria for Salmonella? Anybody know? I'm sure you do. Yeah, just type in the sidebar as you've done previously. What is the indicator bacteria for Salmonella? I can't say it. Enterobacteriaceae, E. coli, EB, EBAC, that's better. Coliforms, TVC, EB testing, EB. Most people are saying Enterobacteriaceae.
Perfect.
Are they on the right lines?
Perfect. Yes, they are.
Okay.
Okay, guys, the correct answer is, as you already mentioned, Enterobacteriaceae. It's a large group, includes important pathogens such as Salmonella and Shigella. And the presence after the post-kill step is a clear indication of post-lethality contamination or process failure. You should not find any Enterobacteriaceae after the kill step. And depending upon the nature of the product, after the sanitation, less than 10 Enterobacteriaceae is acceptable and not above that. Okay. Again, this is based on the nature of the product and microbial risk assessment. Zone 3, these are non-food contact surfaces that are not close to zone 1 areas. Example, walls, floors, drains, ceilings, pallets, etc. If zone 3 is contaminated with a pathogen, it could lead to contamination of zone 2 through the actions of humans or movement of machineries. It is recommended to test zone 3 areas for indicator as well as pathogens. So similar to zone 2, you can use indicator as well as pathogens, and you can go for direct salmonella test or enterobacteriaceae, or you can directly test for Listeria monocytogenes or Listeria species. Zone 3 monitoring is going to show if there is any weakness in building design or poor human sanitary habits. So if there is a positive in zone 3, immediately you should think that there is some deviation in cleaning and sanitation practices. In general, if Salmonella is the pathogen of concern, then focus on zone 2 and 3. If Listeria monocytogen is the pathogen of concern, then focus on zone 1 and 2. I hope this is clear to everyone. Again, this is based on your risk assessment. Environmental swabs in zone 3 areas. The total percentage of swab testing from zone 3 would be around 30 to 40%. That is second highest environmental samples are taken in zone 2 areas. In most cases, it is easy to define zone 1 areas, but zones 2 and 3 are defined conceptually. Please note this point, not by a rigid physical description. It depends on the nature of the finished product and risk assessment. For example, some plant uses, drip shield as zone 1, and some plant uses drip shield as zone 2, and some plant uses sealing as zone 2, and in other plants they consider that as zone 3. I think at the end of the day it should be okay as long as they continuously monitor and verify the cleaning and sanitation practices, assuring the finished product safety. Okay. Zone 4 refers to the areas remote from the product processing areas, example, employee break areas, office areas, maintenance room, etc. If zone 4 is not maintained in a good hygiene condition, it can lead to cross-contamination of zones 3, 2, and 1. Zone 4 is not considered a high risk for potential cross-contamination. Therefore, normally the percentage of testing from zone 4 will be less than 10%. So if you have 100 swab samples, and then just use less than 10 in zone 4 areas. Otherwise, you're wasting time and resources. I think it's time for the last polling question. Simon?
Okay. It's tough today. It's a Friday and so many questions. What is the best method to collect air samples? Okay. So what do you think about that, ladies and gentlemen? Christina Benjamin, an air sampler. Sounds logical. Filter, open air plates, that's Jeffrey and Dawn. Filter, Sion. Air trap, plating, Leanne. Agar plates. Air plate monitoring, diffusion. Impact air sampler or air settling plates. Agar plate. So a lot of people saying agar plates and also some air samplers. Yeah, they're the main two.
Okay, great feedback, guys. I think you know what you guys are doing. That's important. So for air sampling, I recommend collecting the air samples using a small handheld mechanical air sampler, which is more accurate and effective than open plate or sedimentation methods. So you can use different types of agar based on the nature of organisms that you're looking for. For example, nutrient agar for bacteria, and you have to use a different media plates for different bacteria, including mold and yeast. But usually the open plate method and the sedimentation method, it's a very traditional methods, and it just gives the almost I would say qualitative information, not the quantitative informations. For example, if you use a SAS Super 100 microbial air sampler, and which can take like 100 liters per minute and gives readings both qualitative as well as quantitative. I think that gives more meaningful data than just the open plate or sedimentation method. So, comprehensive environmental monitoring program. It is highly recommended to implement comprehensive environmental monitoring programs. What exactly it means? A complete EMP program includes assessing microbiological hazards in all the 4 hygiene zones, that is 1, 2, 3, 4, testing all incoming water sources, testing air samples, employees, means hands and boots, incoming raw ingredients, and finished products. So it's always important to implement comprehensive environmental monitoring program to make sure that everything is working fine as per the recommended specifications. Verification. So it is very important to verify the effectiveness of hygienic zones and EMP in a facility. Environmental monitoring program can be used as a tool to verify the effectiveness of hygiene control measures. One can accomplish this with an increased sampling sites and frequencies. What exactly I mean by that? For example, instead of regular 40 samples, take 60 samples covering additional sampling areas. And despite of increased swab samples, if you are getting same results or pattern, that shows that your existing EMP program is appropriate. Otherwise, if there is any significant deviation, you need to discuss the results with your team and optimize the EMP program. It is always very important to optimize the EMP program with verification. Otherwise, you are wasting your time and resources. The other way of verifying your EMP program is to invite outside consultant or auditor to collect swab samples. So instead of your regular employee, once in a while, like every 6 months or once in a year, invite outside person to collect the environmental swab samples. Again, if you're getting the same results or pattern, that shows that your existing EMP program is appropriate. Otherwise, you have to optimize, increase or decrease sampling. Okay. Reviewing zoning map. I also recommend reviewing and rezoning of hygiene areas if necessary once a year, unless there is a change in the hazard plan, process flow, and other parameters. This is important to cope up with some of the common changes or modifications associated with the company, such as new construction, installation of new equipment, change in traffic flow, increase in overall production, increase in number of employees, and based on the trend analysis, you need to review the zoning map and you have to rezone or reclassify based on the requirement and based on the microbial risk assessment. Summary: a good hygiene zoning and EMP program are more important than ever before to comply most industry and regulatory food safety requirements. A properly implemented hygienic zoning and an environmental monitoring program will act as an early warning tool for potential microbiological hazards in a food plant, identify harborage points, prevents cross-contamination, eliminates product held-up, enables required level of hygiene condition as per the standard, provide signs for root cause investigation, assure overall microbial control, and prevent potentially unsafe finished product from entering commerce. For a successful food safety plan, always design a facility and equipment with sanitary hygiene principles in mind. A good hygiene zoning reduces downtime required for an item of process equipment to be cleaned. A combination of good hygiene zoning and effective EMP program will reduce the likelihood of post-lethality cross-contamination, which is very important. A science-based hygiene zoning helps to build an effective monitoring program. If you have done a good homework of uh, demarking hygienic zoning based on the scientific principles, and that helps to build an effective environmental monitoring program. A successful hygiene zoning helps facility to optimize the sanitation program, thus saving time and resources. The four most important benefits of hygiene zoning and EMP are: number one, it prevents the release of potentially contaminated finished product to market. Number two, it acts as a surveillance system or early warning tool for microbiological hazards. Number three, it provides signs for root cause investigations. Whenever there is an issue, it provides scientific background for root cause investigation. And number four, it provides a valuable legal protection for companies. This is very, very important. Having a good hygienic zoning and EMP program with up-to-date documentation provides a valuable legal protection for the companies. I think that's all I have for today. I think this is the last slide of my presentation before we move on to a Q&A session.
Yes, perfect. If you can switch your webcam on, Kantha, and stop sharing your slides. There have been lots and lots of questions, but obviously with the polling questions, some of those might have been sort of lost a bit far down. So if you did ask a question earlier, perhaps type it in again. Fantastic presentation, Kantha. Thank you. Let's move on to the questions. So Jeffrey, can you see that question in the sidebar? Jeffrey Abrahamson, hygienic zoning applies to whole areas of the plant, while environmental monitoring zone relates to distance from product zones. Oh, you may have different environmental zones within a hygienic zone. Is this correct?
Oh, yes, I think that's a great question. There are good possibilities for crossover. I think what Abraham said is correct. While demarking hygienic zoning, the cleaning and sanitation procedures will be considered. Okay, that's the main focal point. Okay, and while identifying environmental sampling zones, microbial herborage sites is the main focal point, and based on the products, contact surfaces. You are correct, Abraham.
Okay. Right then, I'm scrolling down. Stuart, it's quite a long question. Can you indicate and define temporary zone 1 area as a result of operational processes, a closed system that is opened to change a component such as a filter that comes into direct contact with material, such as vegetable oil, that after the process is completed, system is resealed and sanitized. Thus, is this then zone 2 after operational change?
I think I'll answer this question individually. I hope you don't mind.
Okay.
So please send the question. I need to read it again. Okay.
Yeah, it's a very long question. Irina, what are the recommended air sampling references for different zones? What are critical limits for high risk, middle and low risk areas for air?
Okay, I mean, there is no specific recommendation, honestly speaking. It has to be plant specific. Basically what happens, based on your GMP practices, SOPs and hygienic condition of your facility, you need to go back and look your data for the last 6 months. Okay, you have to spend the time for this trending data to determine the baseline and targets. So based on each facility is unique, and I don't think there is any particular defined answers for this air quality. It depends on the product sensitivity and the final consumers.
Okay, thank you.
But again, you include all the air samples. When I say comprehensive environmental monitoring program, you should include water, employees, raw ingredients, finished products, employees. Okay, both hands and swab. But that's good.
Okay, another question. Hopefully you can see that. Amma, do we need to include zone 1 if we do ATP testing daily on FCS? This is a snack manufacturing company.
Well, that's a great question. ATP provides a very good data. Okay, A snack manufacturing facility, I'm not sure whether they are using meat products or something like that. But ATP will identify that there is some ATP on the contact surface, but it won't differentiate microbes versus plant ATP or meat products ATP. But ATP will add an advantage that will clearly says that there's something is wrong on the contact surface. Take corrective actions. ATP is a good tool. I think you should use that in conjunction with other indicator organisms. That's my recommendation. Apart from the aerobic plate count, and for example total coliforms and ATP, that's really good. And once you get a pattern sequence, you'll come to know like what's happening with the results. So then you can skip one or two, or you can optimize. But I would say better to use in conjunction with any indicator organisms of concern.
Okay, thanks, Kantha.
Great question. Yep.
Okay, Viral, can we cover Staphylococcus aureus and Staphylococcus aureus in EMP for hand swab based on risk, as these may be present on the skin?
Oh yeah, definitely you can use Staph aureus. Problem with Staph aureus is that it's mainly a contaminant from the employees. In most cases, the post lethality handling practices, that is where it is reappearing in the food processing environment. So definitely you can include that Staph aureus, because that's a serious issue. I can check from employee hands and cloths, all those things. So definitely it will add value to the EMP program.
Okay.
Great question.
All right, next one. APICHART. Some facilities I inspected, they put the air in the EMP. Do we need to specify the zone for air sampling?
Well, definitely the zone 1 and 2 is very, very important for air sampling. And again, it depends on the sensitivity of the products. If it's infant formula, definitely you need to effectively implement this air sampling because we are using the filtered air in those facilities. And but I would say concentrate more on the zone 1 and 2 areas, and maybe zone 3, based on the nature of the product. But definitely yes.
Right. Okay. Next one. Teresa, how are zoning and swabbing affected in regards to closed systems compared to open systems?
Well, that's a great question. The closed system, it depends on the cleaning and sanitation practices. But at the end of the day, closed means it's not always like containment free. So you need to check once in a while. And this is my recommendation. Sometimes people think that it's a closed system, packaging material. We should not consider those things. My only difference is the number of swab samples and frequencies. Okay, maybe the closed system will have monthly inspections, monthly swab collection, versus open thing where the weekly or bi-weekly swab collections. But every system need to have EMP program. I hope this is clear.
Right. Next one, Aliyu. I think you might have mentioned this before. What is the role of ATP testing in an effective EMP?
I think I already mentioned this. ATP provides real-time information. For example, for indicator bacteria, whether you're testing for Listeria species or Enterobacteriaceae, at least you need to wait for a day, excuse me, or 7 hours, 8 hours minimum. But ATP will give the results on the spot. But only issue with ATP is that it won't differentiate ATPs from plant, or ATPs from microbes, or ATP from meat. Because ATP is a universal currency agency. Like ATP stands for adenosine triphosphate. All the bacteria and plants and animals have ATPs. So it's very difficult for ATP instrument to differentiate that. But apart from that, it works really great. It clearly shows that high ATP numbers clearly shows that something is wrong on the contact surface, either that has organic material with a plant or animal residue that favors the growth of microorganisms, or that place contains high number of microorganisms. So take immediate corrective actions. So it's a real time, on the spot. It's really good. But I always say use in conjunction with the indicator bacteria to get a good, overview of the, sanitary conditions.
Very good. Okay. Irina, we currently follow 1000 CFU per cm squared for all areas in the frozen poultry, beef, finished goods. However, another reference suggested 300 for exposed food areas. Which one shall we follow?
So can you repeat the question? This is for
Can you
80.
see the sidebar? We currently follow 1000 CFU per centimetre squared for all areas in the frozen poultry stroke beef finished goods. However, another reference suggested 300 for exposed food areas. Which one shall we follow? That's from Irina.
This is a sensitive question, so definitely I would like to answer individually.
Okay, yeah. As Kantha said before, we will send a follow-up. We will send an email after this webinar with the recording, the slides, etc. But Kantha will always also answer all the questions, and we'll send a second email with all those answers, which he did last time. Okay, no problem. Some of them are quite complex.
Okay.
Sana, if pathogen of concern is listeria, do we still sample zone 1 only 10%?
Oh yes, definitely. The concept, you just keep that as standard concept and template. Yes, if it's pathogen of concern is listeria or salmonella, just stick to that numbers. What I say, I think that's really good.
Okay, just a couple more questions. What about EMP in food packaging industry?
Oh, that's a great question. I think during my last presentation also someone asked about that. As I said earlier, for example, last month, I went for a EMP consulting for a bottle manufacturing facility that supplies bottles to, glass bottles to the infant formula and salsa and those things. And because of the FSMA effect, they told the glass manufacturers like we need to have EMP program, otherwise we are not going to buy from you. Okay, that's just in one example, and it can apply to all the packaging industry. And also I heard feedback from the packaging material companies saying that we are getting this request from clients, we need to have EMP, can you please help? I said, yeah, definitely I can help. But the overall concept is, as I said earlier, whether it's a packaging industry or glass bottle industry or meat processing, vegetable processing, bakery, the only difference is the number of swab samples and frequencies. For glass bottles, once in 3 months or once in 4 months is enough, compared to, ice cream manufacturing facility where once in a week or, every day they need to collect the swab samples. So everyone need to have environmental monitoring program. The only difference is number of swab samples. For example, ice cream manufacturing facility, instead of 100 samples to glass manufacturing facility or packaging materials, where like 10 samples would be enough once in 3 or 4 months. Okay. Suppose if I'm manufacturing some product, packaging material that is coming in contact with the direct contact with the food during the packing at the facility, that means you need to do a good job. Although bacteria cannot survive on those materials, but still you need to do a good job of maintaining the sanitary hygiene conditions. Yep.
Okay, very good. Right, I think we're 10 minutes past the hour. I think what we'll do, Kantha, like we said, we'll follow up the other questions by email later. Great job.
Oh, thank you, Simon. I hope this webinar was useful to you. And for those unanswered questions, give me some time. I'll get back to you as soon as possible. And meantime, feel free to reach to me if you have any questions, specific questions which I did not answer here. I don't want to give make a statement that is with universal acceptance. It's not possible because it has to be plant specific, product specific. Please reach out to me if you have any questions about environmental monitoring programs. I'll be more than happy to answer those things. Once again, Thanks for joining this webinar and have a nice day. Thank you so much.
Oh, thank you very much, Kantha, and we'll see you soon. Thank you.
Thank you. Bye.
Cheers. Right. Yeah, I'm sure you'll agree. Fantastic presentation. Cantha does, so I think one of you mentioned there, Alicia, Cantha does know his bugs. Yeah, he knows everything about bugs. What Cantha doesn't know about bugs isn't worth knowing anyway. So yeah, great presentation. We'll send the slides and the recording later. And we will get those questions, any unanswered questions, and we'll put Cantha's contact details in there, so you can actually ask him a question very specific to you. Right, I've loaded the certificate in the sidebar, so you can download that, go to Dropbox, add your name to it yourself, either by printing and signing it, or you can open it in an image editing software like Paint and type it. Okay. Have a great day. Enjoy your weekend. Happy Friday. See you next week.